The Emergence of Semantics in the Chinese Rooms, a refutation of Searle's argument through multi-agent interaction. Author Dr. Ricardo Holmer Hodara, psychologist, cognitive scientist, and linguist. Based on John Searle's original paper, Minds, Brains and Programs, Behavioral and Brain Sciences, 1980. Abstract John Searle's Chinese room argument asserts that syntactic manipulation of symbols, even when producing coherent responses, cannot yield semantic understanding. This paper presents a critical modification to Searle's thought experiment, introducing multiple agents within the room, each possessing monolingual rulebooks in different languages, like English and Chinese. We demonstrate that through blind interaction and cross-referencing of these rulebooks, the agents can correlate symbolic patterns and eventually derive meaning. This process leads to emergent semantics without violating Searle's core premise that agents follow rules blindly. Consequently, Searle's claim that the Chinese room never understands Chinese is clearly falsified. Our analysis shows that the metaphor fails to account for the cognitive capacities of human agents when allowed to interact within a shared symbolic environment. Part 1 Searle's Chinese room thought experiment aims to debunk strong AI, the idea that a computer program can possess genuine understanding or consciousness. In Searle's scenario, a person inside a room manipulates Chinese symbols based on a rulebook written in their native language, like English, without comprehending Chinese. Searle argues that despite producing correct responses, the person lacks semantic understanding, proving that syntax alone cannot suffice for semantics. However, this paper argues that Searle's conclusion relies on an unrealistic isolation of the agent. By extending the room to include multiple agents with diverse linguistic rulebooks, we show that understanding can emerge through iterative, blind correlation of symbols. This modification retains Searle's initial conditions while revealing a pathway to semantics. Part 2 Searle's original Chinese room argument describes a room where an English speaker receives Chinese characters through a slot. Using a rulebook written in English, the person matches these characters to other characters and outputs a response to an external Chinese speaker. The responses appear intelligent, but the person inside understands nothing. Searle concludes that the person is merely manipulating symbols syntactically. Hence, syntax is insufficient for semantics. Therefore, computers which operate similarly cannot understand. Searle emphasizes that even if the person memorizes the rules, understanding never arises. The system, whether one person or a computer, lacks intentionality. Part 3 The Modified Chinese Room Experiment, Multi-Agent Interaction. We propose a double Chinese room with two agents. Agent A, an English speaker with an English rulebook for processing Chinese inputs and producing Chinese outputs. Agent B, a Chinese speaker with a Chinese rulebook for processing English inputs, is able, as well as his partner, to get symbols from the outside or inside the room. One could take the descriptions of Agent A's rules, therefore producing English outputs from his partner's English rulebook, as using his own normal Chinese rulebook. Both agents are blind in Searle's sense. They follow their rules without understanding the other's language. However, they have access to each other's rulebooks and can observe the symbolic processes involved. Part 3 Example of our proposed mechanism. 1. Agent A receives a Chinese input like shui and uses the English rulebook to output a Chinese response wo. 2. Agent A records the English rule segments used, for instance, if input is water, output fire. 3. Agent B takes Agent A's English rule segments and uses the Chinese rulebook to blindly translate them back into English, producing, for instance, water corresponds to fire. 4. Agent B also records the Chinese rule segments used in this translation. 5. Over time, Agent A compares the original Chinese input shui and English description from Agent B, water corresponds to fire, and the Chinese rules used by Agent B6. Through pattern recognition, Agent A notices correlations. Whenever shui appears, it correlates with water in the English descriptions. Similarly, wo correlates with fire. 7. Gradually, Agent A infers that shui means water and wo means fire. Semantics emerge from purely syntactic operations. This process does not require the agents to initially understand each other's languages. They simply follow their rulebooks blindly, but the interaction creates a feedback loop that allows for logical analysis. Part 4, Logical Analysis. Why this is not a petitio principii. Searle might object that this modification smuggles in understanding by assuming learning capabilities. However, our argument does not beg the question. It rigorously adheres to Searle's premises while exposing a flaw in his isolation assumption. Searle's premises are accepted. Agents follow rules blindly, syntax only. Agents lack initial understanding of the foreign language. Key addition. Multiple agents with access to each other's rulebooks. Agents are human, possessing innate cognitive capacities for pattern recognition and correlation. As Searle acknowledges, the emergence of semantics is not assumed but demonstrated through the iterative process of cross-referencing. The agents do not learn in the traditional sense. They use syntactic rules to map correlations between symbol systems. Since Searle's original agent is human, this cognitive capacity is already present but dormant in the isolated room. The multi-agent setup activates this capacity without violating the blind rule following. Thus, our argument shows that Searle's claim that the room never understands is false when multiple agents interact. The room gains semantic properties because the agents inside begin to understand, and according to Searle, humans possess semantics by nature. Part 5, Implications for the Philosophy of Mind and AI. Our thought experiment has significant implications for strong AI, while Searle uses the Chinese room to argue against strong AI. Our modification suggests that multi-agent systems or interactive AI networks could potentially develop semantic understanding through correlated syntax. This aligns with connectionist or distributed AI models. The role of interaction. Understanding may not emerge from isolated syntax, but from syntactic interactions within a community of agents. This mirrors real language acquisition, where social interaction is key. Refining the metaphor. The Chinese room is an inadequate metaphor because it ignores the potential for emergent semantics in interconnected systems. Searle's argument holds only under strict isolation, which is unrealistic for complex cognitive systems. Part 6, Conclusion. Searle's Chinese room argument fails when scaled to multiple agents. By allowing blind interaction between agents with different linguistic rulebooks, we demonstrate that semantics can arise from syntactic processes alone. This refutes Searle's core claim that the Chinese room never understands Chinese. The doubled Chinese room not only performs syntactically, but also acquires semantic competence, proving that thought can emerge from recursive symbolic manipulation. References: Searle Jr. 1980. Minds, Brains and Programs, Behavioral and Brain Sciences. Hodara, Arch original paper. Double Chinese Rooms Can Think, a refutation of Searle's argument through multi-agent interaction. Unpublished manuscript. This document formally presents the idea in English, adhering to academic standards. It includes all essential elements from our discussion. Searle's original argument, the modified thought experiment, logical analysis, and implications. The collaboration is credited as requested.